All right, one more log graphing worksheet. Let's go. So log base 2 is what we notice in this first question here. So it means that ordinarily, the points we would be interested in are 1, 0, 2, 1, and a half comma -1. And then we would create this shape right here like this. And we would have an asymptote on the y-axis. Now, that is not the graph we have here. So do not copy the brown. That is not correct. What we have to keep in mind is that we've got some numbers here. We've got a +8 and a -4. So ask yourself, what do the +8 and the -4 do? Well, this is like x minus -8. So that's going to be 8 to the left. And the -4 outside is going to be 4 down. So if we go to -8, -4. This point, wait, 1, 2, 3. Yes, this point right here is like our new origin. So what that means is that our asymptote will instead pass through this spot. And from here, we're going to draw those same points. So 1 over, 1 up, 2 over, 1/2 over, and 1 down, and we will connect them. And if we wanted to be more fussy, we could plot out a couple of extra points, but that's usually good enough. All right, let's consider number 6 while we're at it, because the same idea applies. We would have had we would have had our asymptote, blah, blah, blah. I can't make nice dotted lines with the mouse. And we would have gone through 0, 1, and 1 comma, in this case, 5, because that's the base. And 1/5 -1. So 5 over, 1/5 over. Again, it's always you go to 1, 0, or 1, 0, yeah, 1, 0 to y equals 1, we go to the base. When y equals -1, we go to 1 over the base. So these are our key points in general for a log graph. But we got to shift this. Specifically, we got to shift this 2 to the right and down by 1. So let's do it. 2 to the right, down by 1. That means our new origin's like right here. So our asymptote has to pass through there. Notice I am drawing the asymptote first. I find that the asymptote is very, very handy for creating these graphs. And now we go 1 over, up 1, and 5 over by ashes, and down 1 and over by a 5th. And that is going to be our graph right there. I don't like how these are so zoomed out. I would have preferred having something that's a little tighter to the origin so we could, kind of actually see what we're graphing instead of just creating a garbled mess. Because let's face it, this doesn't look very neat and organized if we're being honest. But so there's 4 and 6. Now let's talk through the side info here. We've got domain. Well, domain is all the available x values, and that's going to be everything from the asymptote over. So in this case, that started at -8. So we're going to go from -8 to infinity. Infinity is always a parentheses. -8, we do not include -8. That's an asymptote, so therefore that's also going to get a parentheses. Range. Well, we go all the way down, very obviously, and we will in fact go all the way up. It just takes a really, really long time to get there. So the range is always going to be all real numbers. So -infinity to infinity, or do the fancy R thing. All right. How do we get to a y value of infinity as x gets gigantic? How do we get to -infinity as x approaches -8, specifically from the right? I don't know if you'll need to put that plus sign there, but that indicates specifically from the positive side of -8. We can't obviously plug in -8, but we can go towards -8, and that's what this is describing with this arrow here. All right, the x-intercept. Ew. We actually have to answer the x-intercept, not the y-intercept. All right. So it means we need to set y equal to 0, because that's what an x-intercept is. So 0 equals log base 2 of x plus 8. minus 4. That means 4 equals log base 2 of x plus 8. Now I want you to think about, how do we solve an equation like this? We need to undo a logarithm. Undoing a logarithm requires using the inverse, which is an exponential. And the base of our logarithm is 2. So it means the base of our exponential should be 2. So it means this is 2 to the 4th is equal to 2 to the log base 2. That part cancels out, of x plus 8. So x is equal to 16 minus 8, which is 8. So the x-intercept is going to be at 8, 0. And your teacher might want you to actually figure this out and then include it on the graph. So do keep in mind that when I just kind of went wha out towards the northeast quadrant of this graph, you might have needed to actually pass through that point, depending on how fussy your teacher is. All right, and the asymptote is very obviously at the horizontal shift, which is x equals -8. Likewise, for number 6, domain is everything to the right of the asymptote, so that is -2 to infinity, or +2, excuse me, +2. Blech. All right, range is still all real numbers. We get a y value of infinity when x gets enormous. We get a y value of -infinity when we approach our asymptote from the right, so 2 from the right. All right, x-intercept, going to do the same thing. We're going to set it equal to 0. Log base 5 of x minus 2 minus 1. So we bring a 1 over. 1 equals that stuff. All right, we need to undo a logarithm. Base of our logarithm is 5. Therefore, we're going to need to exponentiate both sides. We're going to do 5 to the on both sides. So 5 to the first is equal to 5 to the log base 5 of x minus 2. And hopefully by now you're getting familiar with the idea that 5 to the log base 5, those cancel out and leave just whatever's inside to drop down. All right, well, this is obviously 5, so that means x is equal to 7. So our x-intercept is at 7, 0. Once again, you might consider plotting that point if you don't already have it. We actually should already have it. 3, 4, 5, 6. Yep, I'm on it. And our asymptote is going to be exactly where it looks to be, which is at an x value of 2. All right, now I specifically did 4 and 6 before 5 and 7 on purpose. 5 and 7 have fractional logs, and that's kind of weird. Not gonna lie, it is a little weird. So let's think about what's actually happening with the graph. Ignoring the log base 1/3 for a second, we've just got x minus 4, so that's going to be a shift 4 to the right. All right, well then 1, 2, 3, 4. Ugh, this one. This is 4. So we're going to create our asymptote. And of course, because we didn't go up or down at all, our origin, as it were, is right on the axis. Now, let's think about how we create our graph according to this table right here. We're going to go over by 1. We're going to go up by 1 and over by b. B is a third. We're going to go down by 1 and over by 1 over b. 1 over 1/3 is 3. So down 1 over by 3. And going to look something like that. It's upside down. Because we use a fractional base, it flipped it over. I don't normally see questions like this, but guess what? We're doing them today. So in this case, the domain is still everything to the right of the asymptote. The range is going to be all real numbers. And to get to positive infinity, now positive infinity is the one that goes towards the asymptote, so that's going to be 4 from the right. And to get to negative infinity, well, this is just going to keep going down, 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 down forever. So that's going to be at infinity. Our x-intercept is pretty obvious. It's right on the axis. We already found that point. We went 4 over and then 1 over to make that point. So that's obviously 5, 0, but if you're not comfortable with that, let's consider we just have to solve this expression. So we're going to do 1/3 to the on both sides, and anything to the 0 power is 1. So 1 equals x minus 4, and therefore x equals 5. All right, our asymptote is, again, very obviously x equals 4. All right, so I'm going to clear the screen and zoom in for this last one because I don't like how zoomed out we are for all of this. I feel like it's not really getting us the feel for what we're looking at. So we're going to hit zoom in a couple times here. It's going to get enormous. Oh my God, it's huge. Okay. uh, And now we can hopefully see number 7 just a little bit better here to track what's going on. So let's consider we've got log base 1/4 of x minus 1 plus 1. So the minus 1 here means we're going to go right by 1. The plus 1 means we're going to go up by 1. That's your h and your k, or your c and d if you prefer. Just good old graph transformations. We don't have any stretching, it's just shifting, so it's nice and easy. All right, so normally we would have drawn an asymptote on the axis, and it would have looked like this. However, uh, we have to move it, so it's not going to be this. But let's continue sketching the parent graph for illustration purposes. So we go to 1, 0, we go up by 1 and off the line by b, which is a quarter. We go down by 1 and off the line by the reciprocal of b, which is 4. So that should give us an idea of what the parent function looks like. So now let's create our shifted version. So we are shifting to the right by 1. That means we take our asymptote with us, start with the asymptote. Always start with the asymptote, makes it much easier. And then we're also going up by 1. So our new origin, as it were, is this spot right here at 1, 1. And from here, we're going to create the same point. So we're going to go 1 off the line, up by 1 and b off the line, down by 1 and 1 over b off the line, and we'll connect them. And I want this to go up, 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 something like that. So the pink is your actual. The brown is just the parent function for demonstration purposes. All right, domain. All right, so let's think through this together. Domain is going to be all the applicable x values, which is everything from here over, not including on the asymptote itself, which means we're going to go from 1 to infinity. Range. It's going to go all the way up. It will eventually go all the way down, so it's all real numbers. How do we get to positive infinity? Well, that's up here. So that means that we're going to approach 1 from the right. How do we get to negative infinity? Well, that's way out here. So that's going to infinity. The x-intercept is this point right here, which we've already graphed, or we can solve for it. 0 equals log of x minus 1 plus 1. So negative 1 equals log of x minus 1. I wasn't writing the base, but the base is 1/4. So this is 1/4 to the negative 1 is equal to x minus 1. Well, this is equal to 4 because 1 to the negative first power just means flip. We add 1 to both sides, we get x equals 5. So therefore, our intercept is at 5, comma 0, and our asymptote is at x equals 1. And there you have it.